Hey, afternoon everyone. How we doing? Phew, loads in. I'm actually on time today. I'm all ready. I can't believe it. I cannot believe it. Dear Colin's in first today, look. Colin's in first. Michael Stevens, almost first, Michael. Nick's ready. Afternoon, Derek. Had your jabs this morning. Good stuff, mate. On the up then, Derek. And it is freezing here as well. Really, really cold. It's been a nice day, to be honest. Sun's been out. Michael Hyde, how are you? Nick. Sunny spells but cold. Dennis. Afternoon, Dennis. David Tag. Hi, David. It's Sean. Man Cave. How you doing, mate? Barry Charnley. ZX Harvey. Them caps needs changing. That's on that generic picture that is put up on the stream, is it? I haven't had a chance to do a photo yet, Harvey. Sean's... You going to sit back and enjoy the stream? Sean, you don't get out of moderating duty that easy, Sean. Hi, Rob Cross, how are you? Phil Taylor, hi, Phil. Diode being like a valve. It is, it's a one-way valve, really. Hi, Linton. Benji's in. Hi, Benji. Dave Roberts, hi, Dave. And Doug as well. -3. We did have -2 yesterday, I think. Always on watch, Sean. You can have a rest. You can have a rest. You can have a rest. So let's talk about the power supply that I had to play with on Sunday. The power supply that was 21 volts. And even under load, it was still 17. It was a problem. I mean, first of all, I got an email from Harvey, ZX, saying that that there should be a Zener in there. And I thought, I'm sure there should be a Zener in there. And then like about half an hour later, I thought, hang on, there was a Zener in there. Because I remember pinching the Zener out of it to try in the other power supply. So I created the fault that we spent probably an hour trying to find myself. So I thought we'd put that right first thing. Snowing in Brighton, Colin, yeah. -3.5 last night. So yeah, I thought we'd put this right. I mean, what a fool. No, I want the picture. Yeah, what a fool. So I have a 15-volt Zener to go in this. So those of you that can remember Sunday, I can just remember it. Doesn't seem like more than a day or so ago, really, does it? But let's pop this apart again. I can remember, this is the video. Let me see if I can find it a minute. Come on. This computer's running slow today, people, so apologies in advance. And let's put that full screen. Actually, no, let's put it on normal screen first. Where am I? Yeah, we're there. Okay, so this video was well, this live stream went out on the 31st of July last year, and you'll see up the top there. This is this 3 amp power supply that I popped the lid off. If I go full screen on it, you'll see that there's that diode proudly sat Nice and snug inside this power supply. Of course, I've pinched it, haven't I? I don't know what happened to it. I know I bought some new ones in anyway after discovering this was 15 15-volt Zener. But yeah, there you go. And I think it was Rob Titheridge said to me that serves me right for not putting a label on it to say I pinched apart. Yeah, dear, oh dear. Afternoon, Ninja and Gary. How are you? So, there you are. Another user error. Making my own fault. So I've got quite a few bits to look at today. You'll notice some really ropey looking power supply here. And a switch mode power supply that's been sent in by Simon from Simon's World. He put a question in the forums regarding powering his Hacker Hunter with this one on the back. And he was told by the seller, obviously, that it's an amazing bit of kit. It's wonderful. No problems. He's sold loads of them to Hacker Hunter owners and never had any problems with them. So, you know, my experience of switch mode plug top supplies like that is they're rubbish and they create an absolute massive noise on long wave and medium wave. They seem to be, sometimes they're okay on FM. I've got some up in the loft that I bought in for specifically for the more modern Roberts sets, and they're so noisy that even on FM they're noisy. A load of rubbish. But they do work on FM, to be fair, but you can hear the noise from them. Right, so I'm going to whip this power supply apart yet again. This has been apart quite a few times now. Oh dear, let's just zoom you in a little bit closer. Let's see what I'm up to. Did Mike get a VP408, did he? He got one, Sean, did he? I've not heard from Mike. I don't know if he's not in yet, but he might be in a minute. Yeah, this one was advertised as specifically for... Yeah, Benji's saying the noisy, horrible things. This was advertised as specifically for a hacker. So, allegedly, lots of people have got them and the guys had no complaints. So, but then people probably aren't listening to long wave and medium wave unless they're a collector like us that's messing about with those bands. Most people would just leave it on FM and listen to their local radio station all day long. So, okay. So the hole for our Zener diode is here. Let's get this one across. The hole for our Zener is just there. Okay, can't see it, can you? Where are we? Just in front of those two caps there, look. And I believe it goes that way round with the stripe facing the transistor. Just have a quick look at that on the back. Yes, that's going directly to that power transistor. So I'm going to solder suck the hell out of this. Go and find me sucker. I got my cup of tea in today. So cheers. Cup of tea, scratchy corner. Reminds me, we will have to do a bit of CB radio stuff. I might do that Sunday. Might dig some more of these old CBs out that I haven't tested yet. Yeah, well, we're going to have a look at that in a minute, and we're going to give it a test. I'm not sure how we can test it, perhaps on the scope to see if there's any noise generated off of it. I'm not sure. So anybody that's let's try to see where the pads are. Okay, I think it's these two here. But yeah, mistaken, always the same. Rushing around, do the live stream, and usually when I've finished the live streams, well, the Sunday ones anyway, I'm usually pretty knackered, so I don't tend to hang about. I just go down and crash out then for the evening. Okay. So I think what I'll do is I'll get rid of those marks that I put on the board that I totally ignored. When I went to put the capacitors back in. Cathode. Hi Rob, how are you? Rob Titheridge, that is. Cathode. Cathode to the power resistor. Now this gluey, mucky stuff, I don't know what that is, but we have replaced the caps on this, so apart from a refurb, this power supply should be good to go. You know, apart from a respray, and perhaps I was toying with the idea of replacing the electronics in this and just modernising it a bit. So I'm not going to pull it tight to the board because the other one wasn't tight to the board. Let's flip it over. Bit of glare, that's that light up there. Oh no, the other light's glaring as well now. They're all glaring. Yeah, I think I can't get the glare off of it. Can't get the glare. That's better. Okay, that'll do. So let's solder this back in and then we can test the thing then. But you know it is. So that lot. So say I bought a load of 15-volt Zeners in last time. I think this is a BZY85C15. Let's give that a bit of a defluxing. It's pretty rank, isn't it? Daniel, how are you? Having a tea break? Good stuff. Let's get rid of some of this flux. I say I'm undecided what to do with this. 3 amps was a popular size. Everybody was winding up their CB radios back in the day, and they were trying to squeeze as much out of them as they could. With a bit of tweaking in that, you used to be able to get around about 8 watts out of a CB, if you were lucky. So anybody that had them at a higher power, you used to switch over to the 5 amp power supplies. God, look at the state of that. That's filthy. So I've been playing with this PCB design software again as well with Chris and Rob and other people that have been helping me, it's gradually sinking in. One thing that is very difficult for me to try and work out is the actual track size. Now there is calculators out there for track size, but it wants to know lots of bizarre things that I don't know. Like how many microns thick is it? What ampage is the current going to draw, and all that sort of stuff. That's a lot nicer. There we go. I've treated it. As soon as I upset it, I've treated it to a nice clean. A nice clean. How are we doing? 24 inches in the last week. Won't be seeing your garden till spring. Yes. Yeah, CBs was your rig. And you always had your local rig doctor, Sean, that used to do all sorts of weird and wonderful things to them. So I say, I have got quite a lot of CB stuff that I've sort of started working on and I haven't finished because I've got other stuff in here to fix. But I do like to try and sort out my own stuff on a Sunday, so it might be that Sunday we'll have another play on the CB stuff. Doesn't excite everybody, I know, but it is still radio. We are still repairing stuff. Servicing stuff, that sort of thing. And it's a get together. Let's pop these washers on. It's a bit of an awkward place to get to down there. It's not the greatest. I think I had to actually put these in the socket set last time, didn't I, before I actually fitted them on. You were that rig doctor, ZX, were you? So you were the man that could squeeze 8 watts out of a Harrier CBX. What did they used to do? They used to change the driver and the output, was it? I can't remember now. But I don't think the actual original output could handle 8 watts for long. But I know there was. I think you could actually trim them up to near 8 watts. Just on the trimmers, but obviously totally illegal, being that's 4 watts is the max. But, these days it seems that everybody in their, what's the expression? Everybody and their brother's got an amplifier nowadays. You like learning about everything. Your garden's vanished in white. Yeah, we haven't really had anything settle here as such. There was a bit of snow settled, but it didn't last for long because in come the good old rain again and washed it all away. Right. There we are. We have a Zener. At long last. So I'm going to pop the lid on this just for a bit of extra safety, I suppose. Just so I don't stick my hand in there. I noticed when I was messing about with that other power supply, I kept sticking my hand in the thing. And I did touch the terminals that I touched the terminals that I masked off, I taped up, so it's just as well I did tape them up. But then I suppose taping them up gives you a bit of extra confidence, perhaps, and maybe you don't respect it quite as much because you know that it's safe-ish. But yeah, I'm not going to do anything else to this supply if it decides to blow up now. Oh, the lemon LEDs come out, look. That's another thing to do, is to glue the LED in place. It might be an incandescent bulb on this, I'm not sure. Yeah, LEDs dropped on the floor. I think you can still get these LED holders. I haven't actually got any, but I say I haven't got any. I think I have ordered some in. I think I have got some, but they're in amongst all the stuff to build the Commodore 64 power supply. Another job. Xena stealer I am. Xena thief. Squeeze them up to 8 watts, not all on the same frequency. It's just stabilised, the front label lies. Now Richard from UK CB Radio Servicing sent me a very interesting schematic to build a CB radio power supply, which did look pretty good. But I think it would be quite costly to build because of the transformer cost. It's quite a hefty transformer on these. Certainly a lot bigger than the piddly little ones we've been playing about with just to run a transistor radio. I've got one that's not got any thread left in it there. Okay, it's time then to play again. We on or off? We're off. Plugged into the mains. Let's get the jet fighter engine up. Let's wire this up. This is the load that I bought off Amazon. DC load, which is proving very useful at the moment. So it was a good investment, I think. So I've been busy trying to sort our bathroom out again after the problems with it leaking and ruining some of my radios. Okay, let's have a look at our power supply, 12 volts. Let's pop that in the back. Turn off load, power on. Okay, good to go. So I think you can see it's probably not the safest thing to prop it up with, is it really? But haven't got anything safe here to prop it up with. There we go. Let's just go warp our brush. So you can see the display a bit better, that's all. So let's pop it on. So instead of 25 volts or 21 volts, we're now 13.5. So that's definitely that Xena, isn't it? Oh well. You bet it uses a UA723 chip, common old regulator. Yeah, no, it's a transistor, wasn't it? It was a D325, what's that? I can't remember now. Okay, so from the power, it's drawing 30 milliamps. So let's wind the load up. So it should do 3 amps and it should stay around, well, it's 13.6. Let's wind it up. So it's dropped to 13 volts. So we've lost 0.8 of a volt at 1 amp. Let's get it up to 3. It's dropped down to 9 at 3 amps. So that ain't great, is it? I mean, the typical CB, to be fair, is going to run sort of 1.2 amps when transmitting. So really, it's a 1 amp power supply, isn't it? So if I go higher, 4 amps, it's down to 6 volts, look. So it really is dropping off. Yeah, it starts dropping off after an amp, really. I suppose it's usable at 2 amps, 12.8 volts, but it's dropped nearly a volt. 2.5 amps. Yeah, it drops right down to 10. So there's no way it's going to do 3 amps. So there you are. Useful little test. So it's usable now for a normal CB, for your usual average sort of CB, but it's 2 amps if you're lucky, really. I don't know if that's down to the transformer in it, because it is quite a lumpy transformer, or whether it's just down to the circuitry in the thing. So there you are, it's back. So the only protection is the fuse. Ninja, yeah, it certainly is. It won't cut off, Sean, no, it just starts dying off at if you overload it. So the voltage drops right off if you put too much of a load on it. What do they call it? The transformer saturates? Is that what? I really don't know. As I say, I don't want to speculate, but I think there is a name for it. Is it saturation of the transformer? Anyway, this might be of interest. We've all been tempted to buy the Wonder power supply, haven't we? It's so cheap, it's unbelievable. Now this has been sent in from Simon. Simon put this on the Hacker IO Group's IO site, on the Hacker Group. He'd been sold this by by an eBay seller, and claiming that it was fine, no problems at all. But he queried the polarity first of all, because this is center pin positive. So I think before he plugged it in, they actually sent him like a gender changer here, which has changed it from center pin positive to center pin negative now. But it's clearly, does it say switching? I think it's in the description, it said switching power supply. It's not, I mean, it's nowhere near heavy enough to be linear, not at all. It's got a picture of a fuse there, but it says 130 degrees C, so is it a temperature rated fuse? I'm not sure. So 240 volts AC at 50 hertz, which is right. So it's got 18 volts DC at 300 milliamps. Well, we know from testing Hacker at the weekend that on full whack they will do 300 milliamps, but saying that, you're not going to be running a set that high, to be fair. So, you know, looking at that, it should be perfect, shouldn't it? In theory. Simon, 28 volts output, eh? I bet you have stolen the second reservoir cap. Center negative is the work of the devil. Oh dear. So what the idea is to start off, we'll pop this in I'm going to have a job connecting this up. I should be able to just ram that in. So we'll see first of all if it is center negative before we start sticking it on the load. So let's unwrap it and see what it's doing, because the switch mode power supplies apparently don't like being wound up on variac, so it's going to go straight in at 240 volts. So one of the things of switch mode power supplies, they are a lot more efficient than linear power supplies. I mean, it's sat drawing next to nothing output at the moment. Right, so what have I done with my multimeter then? Anybody know? Anybody see me? Oh, there it is. Very deep. Oh, the 3 amp supply. No, it's got a brand new second reservoir in there, Harvey. I'm not guilty of that. You can't put that one on me. Right, let's have a look what it's outputting. Let's turn it on first, would help. So Sam is quite right. It's outputting 27.14 volts. Which, I mean, for a switch mode power supply, I would have thought that would have been regulated. It doesn't say regulated on it, does it? But Simon was quite right. He didn't really want to plug that into his nice hacker radio and potentially overheat the outputs. So definitely right, it is center pin negative. I mean, I've got the negative in the pin in the middle and positive on the barrel. And it's 27 volts. Center pin negative. So let's see if I can hook this up a minute. Stick it onto the load. No. Turn that right down. And we need to ram the other one in the center. That'll make a good enough connection, hopefully. Let's get the meter out of the way. Let's get the load loaded up. There we go. Right. Power into the load. So there you are, 26.7 volts. Can't really see that very well, can we? We need to just angle it up a bit higher, really, so you can see the whole display on it. There you go, 26.7. One of these lights is taken out. Is it that one? No, that's my main light. Right, let's bring it up on a load. So it's supposed to do 300 milliamps. So let's pull it up. Well, there's 300 milliamps, and it's still doing 17.3 volts. And it's pulling 40 milliamps from the mains. So that ain't suitable for running it, is it? See, David, you know, that is a 300 milliamp load, look, and it's only dropped to 17.2. So you were right, Simon, to query it. I mean, this is a brand new power supply from eBay. So buyer beware. If you see one of those advertised. Well, saying that, actually, no. What am I going on about? That is okay, isn't it? What am I going on about? That is okay. Because we're looking for 18 volts, aren't we? So really, we're not going to be looking at much. Well, saying that, it's 21 volts at 100 milliamps. So let's see where it drops to 18. So 18 volts is correct at 250 milliamps. So it will go down. I'm cracking up. I'm thinking it's 9 volt. Of course, it's 18 volt, isn't it? Yeah, I know what you're saying, Harvey. If it's unregulated, you would have to, wouldn't you? But it doesn't say it's regulated. It doesn't say it's regulated. It's got EMC EU on it. So whether it's past some sort of EMI test, but as I say, it's still, you can see the voltage is still sat at some 24 volts, so there's a capacitor in there that's still working. It's unplugged. So that PSU is crap. Yeah, I think it is. Anyone can print out a label. Yeah, I know what you're saying, Ninja. I can't quite read it. It says, looks like ITB or something written on it as well. ITS. So it conforms to EN61558. I don't think I'd be sticking my hacker on that, to be fair. I mean, it would, I'm trying to think, 2 9 volts fully charged. They're going to give you, around 20 volts, I would think. So it should be able to cope with it. I'm just trying to think what I can try it on to try and blow the radio up, because I'm quite good at that. Let me go see if I can find anything in a minute to plug it into. What have I got? What did we blow up the other day? I want something with a power socket, ideally. And one of the later Hunters would do it. What have we got written on this? Okay, I've got an old Hunter here that I've got in for restoration. I've pinched a knob off of it by the looks of it, and it's a bit dusty. A bit dusty bin. Where's my cleaning cloth? Don't know where my cleaning cloth is, but it's a bit dusty. It's a bit too dusty for the bench, really. Oh, there he is. Crack, it's open. It's not heavy. I mean, it's really light. It's got some imitation vents in it. It's really light. It's not a. Well, it could be, I suppose. But I don't think it's linear. Let's just try it in a radio first. We've got to make sure this radio actually works. I don't know if it does. It's a pretty rough rough one, but it has got a center pin negative socket in the side, so we're not going to be able to check the load, but we know still got 6 volts in it now. Let's get this out of the way. So I'm going to risk it on my radio, but we'll see if this works first of all. Because no point plugging it in if it don't work. Where's my clip lead gone? Right, we're on there. 3 volts. Show 18 at the back end of it. Yeah, it's a bit of a ropey old radio, this one, but you know. So really, it's not going to work on medium wave and long wave, is it? Okay, we want it to work on medium and long wave because that's where we're going to see if there's any interference. Let's just zoom out a bit close on I. So it's dodgy switches as usual. Just pop that power supply off a minute. That one's decided it doesn't want to latch now. Right, let's try that again. Now working on medium wave. So there's a little bit of noise on there, which is probably this. Yeah.
What's your, after today's disappointment then, Liz, what's your next step?
Keep fighting, make sure that everybody knows that it's not just the cladding and it's not just building over 18 metres, that there are a multitude of problems and that leaseholders across the UK are facing the turmoil, both financially, safety.
Okay, let's disconnect it from the batteries then. Let's give it our power supply, and I can monitor the. Can I monitor the power on it? It's plugged in. Let's see if I can set the multimeter up to just have a look at the power drop as it comes on. So really at low voltage this is going to be quite high, isn't it? We can hear that noise already, look. I think it switches out the, yeah, it switches out that. Yeah, that doesn't sound good, does it? That doesn't sound healthy. Hang on. Have a quick look here. So input, ground, HT. It's difficult. I can get onto the HT easy enough with a clip. To measure that. Got to be really careful because if I short that, then it'll be another load of. So if I go to there. No, it didn't like that. Let me see if I can measure it with this. Let's get you down on the. So there's a hum you can hear there. Oh. It's just me knocking the connection. Can I go across here? Now 2.6 volts. Yeah, so that's got that 26 volts sat on it, look. That's not great, is it? Let me just connect this up to my lead so I've got one hand free. We can crank it up a bit then. Too much.
We need to be in the best place possible to be able to respond to that.
Let's take it issue by issue, because there are so many different things that are woven in here. First of all,
They're one of these Welsh field hospitals.
Third, and this is more of a do than a don't.
That is the noise, I think.
Well, it's absolutely critical that we as negotiators are genuine, sincere,
So remember that noise.
likable, and not just perpetrators, but hostages too.
But I don't think that anybody was sleeping because it was so...
So remember that noise. Let's connect it back up to the power supply and see if we've still got that same like helicopter landing noise. Where's my other lead gone?
Psychologist Niels Beers has an idea.
Oh, hang on.
What if we bring a family member?
Hang on. Don't forget, it's still...
So they fetch his brother. He goes down the stairs to the bank vault. He shouts, don't shoot, I'm your brother. Yana starts shooting. The hostages are terrified. What sort of maniac would shoot at his own brother? Only it isn't Yana Olsen's brother. Remember how Yana had entered the bank in disguise? The police thought he was someone else. They brought in the wrong brother. Every time the police intervened, the risk to the hostages...
No, it's not that.
...not decreased.
Well, it's not really any noisier. It's not really any noisier. We haven't really proved anything, have we? How can we prove anything? Hi, Dave, how are you? Dave Rhodes. So let's introduce it to the voice of truth. I haven't got a big voice, unfortunately. It's certainly no good. It is too high a voltage for that radio, definitely. I mean, it's not dropping at all, is it? I put that on pretty loud, and it was still up way over 20 volts. Short term, it wouldn't be a problem, but I think if you left it on for any length of time, you could potentially damage the outputs. I don't know what voltage they're good for, but yeah. So our Yao Simen Town Wanji Electrics factory is too high. I don't think I can get it apart, but we'll have a look. We'll have a try, shall we? We've got an even nastier supply to look at next. I've got a couple radios here as well. If we get a chance to have a look at those, we could do with just a quick overview to see what's up with them. See if we can get it apart with Spudger. I doubt it, because I mean these things have got to be pretty. Simon has let me have this, by the way, so I can destroy it if necessary. I don't really want to go in there mental, because there still could be some voltage on some of the mains caps. What can we whack it with? Just try and break the glue seal on it, really. That sounded a bit snappy, didn't it? Crack her like an egg. No. Shall we cut the top off? Let's cut the top off. Shall we cut it off? This afternoon. Naturization? What's what? Ultrasonically welded. Hammer and chisel. Came with whack-a-mole. Be interesting to open it up and have a look, won't it? Let's get her open. Let's get the old razor saw out. Where's my other razor saw? Two of them here. Nice metal saw. Don't try this at home, children. I'm trained in the use of a razor saw. So I'm going to cut my hand off now, aren't I? As long as I don't cut straight through the transformer, we should be okay. Come on, surely it must be a pot by now. Oh, that's a big one. That's the biggie. I'm trying not to damage it too much. I mean, we can... Oh, hey. That went deep. That went deep. Didn't like it. We're in. We're in. Overhead cam time. Let's get in this beast. Let's get in it. The big reveal. Snippy snip snips. Is that a linear transformer? The wires are twisted around about 4 times. Well, I think that's a linear transformer. A linear power supply. Mike, how you doing? In and out. What were we talking about you just now? There's us expecting It's not, it's nothing. It's shocking, really. It literally is. I mean, it's warm. It's a little 470 microfarad, 25 volt. Oh, hang on. Oh, it gets better. It gets better. Look at this. we've got a dry joint on it. Look. I don't think you're going to be able to see this or not, but capacitor's not connected. Wow. I'm surprised. That is a linear power supply. 300 milliamps. That's a tiny, tiny transformer. So we've got a little tiny bridge rectifier in there, made up of diodes, and shoved on the output. And we've got a resistor, a capacitor that's not soldered. There's no regulation at all, is there? Absolutely no regulator on it. It is literally whatever you turn it up to on the mains is what's coming out. I'm surprised. It is literally 4 diodes in a cap. Wow. I mean, how could you have fitted a regulator on that board? I mean, if this was SMD, you could probably, couldn't you? Very interesting. So I wonder if it's because this is dry jointed that we've got that problem. Let's solder that on. I mean, it was holding its charge, wasn't it? But yeah, that capacitor there is just not. It's not connected to anything. That it's Oh God, they can't even solder the board in straight. That literally thrown together. I mean, the laminates are very loose on the coil. You know, there's no fuse in it, I don't think. There's nothing in it, but it is a linear power supply. I'm amazed. That's well worth taking apart, wouldn't it? So what do we need to do to that? China 1, UK customs 0. It is cheap, Doug, but it's doing a job, isn't it? It is doing a job, and it is what they say on the box. It's no wonder I was surprised that we weren't getting any interference from it. Now we know why. And this looks like leaded solder as well. I mean, this is amazing. Where's my solder sucker gone? Is a temp fuse behind the green plastic, is it? It could be a fuse in there. I don't know. It might be a resettable fuse built into it somehow. I can't see in any way, but you never know. Yeah, I think it's unleaded solder. Let's put a good old bit of leaded back on it. I'll just solder this one to hold it in place, and then I'll take the other one out. That's got it. Let's just do the other one as well. So yeah, I'm sure you could make up a little board, a little regulator board in there. There's enough room with SMD, I think, to squeeze a regulator board in there. Can't remember whether the thing was in here now. So we'll have a look and see what it's doing now that I've fixed that fuse. Fuse? Fuse? Where's it goes? I can't stick a bit of tape around it. There's a cable tie. I'm going to stick a cable tie around it for a minute just to hold it in place. Hi Andy Tobin, how are you? Right, I'll just hold it back together a bit safer for the time being. Let's have a look then. See if that has made the difference, because if it has, then maybe we could recommend it. I don't know. It needs... It's the most basic. I mean, I've been trying to build a power supply, but Christ, that's basic. No, it's still 27 volts. Let's see what it does under load now. See if it changes under load. I don't think it's going to be any different, to be fair, but we'll give it the benefit of the doubt. It did actually say on the advert that it was switching, you know, which is really weird. I don't know. Right, can you see that? What do I have it? Oh, I can't. Yeah, it's so at 40 milliamps, which is where you would probably normally run a radio, it's 22.9. Yeah, it's not changed, does it? It's exactly the same. exactly the same, but it's worth a try, wouldn't it? Interesting to find the dry joint in it, brand new power supply, but yeah, an actual linear power supply. That's hence the reason why there was no noise. So still got a bit of tea left. It's cold. With cold tea. And Doug is saying you could build a regulator circuit into a separate box and plug the PSU into it. You could do, Doug. But I mean, it would be fun to try and make a little microscopic board to go in there with perhaps some SMD stuff on it. You can get 4007s in SMD. You can get an SMD 7818 regulator, I think. You've got enough room to put some little components in there and make it a regulator, but it's actually unregulated. So something's gone amiss there, isn't it? Because that is not a regulated power supply. It's not doing 18 volts. It's doing 26, 27. But that was really interesting. So Simon, thanks very much for sending that in. So there's a final look at our power supply. Hi Ganesh, how are you? Naturization. What isolation? You asking what isolation transformer I'm using? It stands BS. Yeah, it is BS, isn't it, really? But it has got that EN number on it, isn't it? So Yao Simin Town Wanji Electrics Factory produced that. No SMD needed. It wouldn't fit the socket without an earth pin. There you are. So that is a bit of a fail and a pass, really, isn't it? Because it is a linear power supply, which is why there's no issues with any comebacks on the seller, because people are plugging it in and they're using it. I mean, I will investigate that a little bit further at some stage. We'll look at what the secondary is on it. Well, it's got to be. What's the secondary likely to be on that? 24 volts or 18? No, it can't be 18, can it? It could. Well, actually, it could be 18 volts, couldn't it? Because when it's been rectified, the voltage would go up to about 20 odd. Interesting. But 300 milliamps, I don't know that I'd want that running at 300 milliamps for too long. There's no ventilation in it, although there's room for ventilation, but then if you cut ventilation slots in, you'll get a mechanical device in there and potentially touch one of the pins. So there you are. So thank you very much, Simon, if you're still there, for sending that in, mate. That was very interesting and a bit of an eye-opener. So, I think this next one will be of more interest to you guys, because again, we've got another potentially possible power supply project Too many power supply projects. What do you think of that? Homebrew. You would need 21 volts to run a 7818 regulator on full load. Full load though, what would that be? That would be an amp or so, wouldn't it, Harvey? We'd only be looking at sort of probably 300 milliamps as that was really. So this is a copy of, well, I think it's a copy, I don't know yet, it's a bit scary. It's a sort of copy of one of the Hacker PP9 mains powered PP9, if you know what I mean. I'm trying to think. Let me see if I can find it a minute. Let's get you in a little bit closer. You can have a little nosy, a sneak preview inside it. I can't remember what it was called now. Can anybody remember the Hacker the Hacker 9-volt mains battery eliminator? Eliminator with an E on the end of it. I'm trying to think of the name of it. I'm just doing a quick Google search to see if I can find a picture of one for you to have a look at. They're very rare. I haven't ever had one here. I've seen them up for sale before, but obviously you can use them in any radio that uses a 9-volt PP9. Ah, there we are. There we go. Open link. We don't want to open the link. Open image in new tab. So this is the sort of thing, I mean, this is just a picture I've just grabbed off the internet. So this was available from Hacker to replace the PP9 and make it into mains power. You had to cut a little notch in the case. You basically popped your battery snap on top of this, and then you plug this into the mains. I don't know if anyone's reverse engineered this or it's got one that they could take apart and draw out. But these are pretty rare. I haven't ever seen one. I've seen them on eBay, but very, very rare, and they're gone pretty much straight away. Very often you'll see one actually bundled with a radio for sale. But it's only 175 milliamps. Then 9 volts, so yeah, that's probably going to be okay for a 9 volt, isn't it? Not that there's that many 9-volt Hackers out there, to be honest. So this would have been, you know, you can tell by the badge style, this is probably one of the 1970s type radios. Possibly the Harrier, perhaps, Avimore, that's that sort of range. Ranger, that would have been when this was available, I'd have thought. Uncle Fester make this have a PP9. It just pulls out a container. Yeah, I've not revealed it fully yet, Simon. So that's a good little project again to maybe build something like that. But that is a metal cased one. So a few things with this. I mean, this is only the low voltage. So whether someone's robbed this little power supply out of something else and shoehorned it in this box, I mean, we've got an older style plug, unshrouded. Let's have a look at what sort of fuse we've got in there. It's got 3 amp. Let's check the wires. Not going to pop out or short out on me, no. Okay. Oh. Just pop that back in, so that's safe enough to use on the bench, but it's obviously not safe for normal. It certainly ain't safe for normal use, is it? It's great, I love it. So let's pull the battery terminals out a minute. I'm going to leave it in its little box. So I think this is just a normal. Yeah, it's a normal not regulated, it's a normal linear power supply. But I'll leave it in its box just to mean that I don't have any mains floating around. So we can pull this up gradually on the variac, which will give me an idea if we've got any short circuit. I'm not going to load it for a minute. Let's zoom out a little bit. They did an 18-volt one as well. Really, I've never had either of those. Right, let's hook this up. Let's get me here. Leads. Shush. Negative. So this is very similar. Yeah, just clamp it on. So all they've done is the same as what I've done when I made up this this adapter here. So I've just marked on there. So I've just put some heat shrink sleeving over the wires there to disguise that they're now reversed. Right. Let's get everything out of the way of it. And let's wind it up. $50 volts. Would have thought I'd have got something at 50 volts. No, so there's obviously something wrong there. Either one of my clamps is not connected properly. That one looks to be. Let's try that again. Okay, so nothing's happening. Let's just quickly check the fuse. The Chinese would be cloning it. Check the primary windings. Let's go from the fuse first. Let's see if we've got a fuse. It's just dumped the earth pin ceremoniously out of it. Yeah, we've got a fuse. Okay. It might just be my leads. So let's just go on to DC and I'll measure. No, there's definitely nothing on the output at the moment. I mean, it's not drawing any current either. So I've just wound the power back to nothing. Oh, that's not very healthy. Oh dear, oh dear. I don't know if you can see that, but that's not the greatest soldering job on the planet. We've got these wires here, look, just waiting to jump onto the other terminal. Dear, oh dear. Let's just see if I can solder that on a bit better a minute. Okay, so got all the secondaries on the thing. I mean, let's just zoom out a little bit. So this is our primary winders. I'm on 0 volts here and here, and this is our secondaries. I'm going to take it that's. Yeah, so there's our little bridge rectifier there. Looks like we've got an LED there and a neon indicator there. Unless that's being used as some sort of fuse, perhaps. Okay, so we're gonna have to get some. Gonna have to get down and dirty with it now, aren't we? Can I just prop it back in the top of the box there for a second? Just prop it up so it's a little bit safer. Right, I'm going to wind the power up. So let's just make sure I've got AC coming in to start with. So let's go up to 60 volts. Okay, so we've definitely got AC coming in. I'm not sure which terminal's which on the output though. It's got loads of different tap-ins. I mean, I think possibly that's... So let's switch up to DC. If we go with that as the negative. Hang on, that's still AC, isn't it, you fool? Dear, oh dear. So it looks like we've got different tap-ins. So that's, I'm assuming that this is the ground. Okay, well AC is... Well, that's definitely one of the connections to the bridge there. I'm assuming it doesn't matter which way round, does it really? It's AC. So 2.5 volts, 2.1, 1.85, 1.5 and 1.1. So we've got lots of different tap-ins there for some reason. So let's wind it up a bit further. You can't really see what I'm messing with there, can you? Let's let it sit on 100 volts. Oh, I reckon that neon's gone open circuit. You know, I think that's been used as a fuse. So we're on 100 volts now. Let's go on the... So we're looking at 4 volts. Whether these are combined, I don't know. So 3.8, so it looks like it's, let's go right the way up to 240. Oh. Sort of heard something then. Let's leave it at 150 for a second. .7, okay. So we're now sat at 240. That isn't illuminating at all. So we've got our 9 volts there. So let's just pop that back off a minute. So get that back out. Let's have a closer look at this. So I'm disconnected from the mains. Let's try and get you underneath the overhead camera so you can have a look. Goat curry. Just catch up with the chat a minute. On the wrong camera. Should we call them house fire joints from now on? Twist the black stick. Twist the black stick. Oh my God, look at that. Simon's saying this is some sort of weird and wonderful potentiometer here. Look at this thing. So someone's just said twist the black stick. So the black stick being this thing with a slot in the end of it. And looking underneath the board, it looks like there's a wiper, and you can see the wiper is just off of the track. So if we turn that wiper, so it's on the track. This is lethal, isn't it? Let's try that. Let's try that. Oh my God. It's all good fun. Let's try that then. Have you actually had this working, Simon? No, I mean, I'm up to 100 volts there, look, and we're still not moving at all. Being careful because it is very precariously balanced now. I'm not sure which is ground on the output, so it should be across that filter cap, shouldn't it? If I can find out where the filter cap actually is. Where negative is. Okay, so it looks like it's there to there. So let's measure across the filter cap. Just there to there. Oh, steady. Nothing. Unless there's something wrong with my meter, there's nothing there at all. George. What are you on about now, George? I know how much I got turned down, and as Graham keeps saying, he's poor and needs super chats to eat. I don't recollect saying that, George. Afternoon, Aston, how are you? And Dom as well. Any magic smoke bin let out? No, I've got 240 volts sat on my lap here at the moment, though. Nothing, nothing coming out of it at all. I'm just wondering whether that bridge is actually working. So I think that's that. Let's go there. I think that bridge rectifier is dead. Let's go across the AC part of it. It came in a Dynatron Elan and it worked. It don't seem to be working at the moment, Simon, but so that is definitely a across the AC, which I'm in AC. So DC plus and minus is there. Okay, so it goes through this neon here. So I have got it all unplugged again. Okay, it's a little bit of a strange setup. I've not seen nothing sort of like this before, but you know. So these 4 pins here are the bridge rectifier. Between these two is the AC. So this is coming off the transformer, which is good. But if we look at the other AC pin, which is actually, yeah, that one. So that's the other AC pin there. And that goes up and into this neon. Then this is sort of selecting the voltage somehow with this weird and wonderful, almost like a homemade potentiometer. I don't know, I can only see one terminal on it. Yeah, there's only one terminal on the potentiometer. Eh? Oh, I see. Hang on, no. Right, okay. So the body of it is 1/2 of the terminal. So let's try that. So now I've got it on the next track along. So this is actually the body of it. So it was actually set to the body. So now it might work. So now we're actually putting it from that track back through. Okay, let's try it again. Let's try it again. I'll be interested to find out about your comment just now, George. I'll message you a bit later about that. It's a bit naughty, that. So we'll have a little chat about that, I think. So let's try again. So I'm sat at 0 volts at the moment. Right, let's try again. Ah, now it's moving. We're moving. Okay, what's that weird little potentiometer thing? So we're set on 100 volts and we're chucking 4 volts out. $200 volts, no neon, no neon. Let's get the neon cam going. Eight and a half volts. You see the neon because that. $240. I don't think there's a. Oh, no, the neon's not lit, but the LED is behind it. Yeah, the LED's lit, but not the neon. I'm just trying to move this without electrocuting myself. Yeah, so I'm not really sure what the purpose of the neon is. I think it's just there is some sort of weird and wonderful fuse. But that's just the LED you can see there. So we're at 10 volts, so assume that moving this little potentiometer around, 8.9, 7.4, 5.8 and 4.29. So let's go back up. $8.9, so that's 9 volts. The full whack then it's doing 10.5. It's a bit high. Let's turn it back to 9 volts. I'm just going to turn it back off again a minute. Then we'll stick it on the load and have a look. See what it'll actually put out. So again, there's not a lot to it. If we have a look up a bit closer. So this is the output. So we've got a bridge rectifier there. One of these like little cylindrical packages, a filter cap. We've got this I don't know what this is. Is it a neon? Is it one of these gas discharge things? I don't know. I'm really not sure what that is. It looks to me like a neon. Then we've got an LED in this like sight tube. So I'd assume that at some stage this would have sat in something with that just drilled through the top and a hole drilled for that. So you can adjust the supply voltage. Turn that light back on again. So you can adjust the supply voltage very minimally with that. But it does explain why we've got all those tap-ins on the back though, doesn't it? It does explain why we've got all of these. So they're just very slightly difference in voltage. So this is the highest voltage tap, and that gives out over 10.5. That's just under 9, and then it drops back to, I think it was 4 on the smallest one. So you could use this as a 6-volt as well. Interesting little bit of kit, really. Very basic. I still don't know what that thing there is. There is some markings on it, but they look to be mostly rubbed off. Let's have a quick look, see if I can see what the markings are. It just says 051 is all I can see on it. I think it's a little fuse of some sort. I don't know if you'll be able to see it on the camera, but it does look like some sort of, it's not got a filament in it as such. It's almost like a bimetal strip. You can't really see. I'll turn that light off there, maybe. Not so much glare. Yeah, you can sort of see that. So it's like 2 poles, and this comes across. This side is fixed. As it loops back over, it's making contact there. But there's a little bit of heat on that. So I think possibly if this overheats, this might be a bimetal strip that just pulls back. So it's almost like a self-resetting fuse. Old style. Old school self-resetting fuse, I think. It's adjustable 9 to 12 volts. The bulb thing is some cutout device. It looks like it, yeah. What's Aston saying? Reminds me of the ones you used to get when you wanted something to power a grandstand game. Those were the days. Yeah. 5:30. I'm running out of time, really. So all we want to do is just stick it on. Oh, hello. That's just come off. Great. Where was that attached to then? Okay. There's a bit of corrosion on that for some reason. But yeah, that's just come off. So we've got to repair it now. Where are you? Yeah, so it is a self-resetting fuse, isn't it, Doug, really, basically? Let's just get this off here a minute. to repair it before we can test it. Okay, let's stick it back in its hole. There we go. So let's have a look. We need to hook these up. Oh, steady. Nice litre of rubbish. Okay. Right, there we go. So we've got the load. Turn down, let's power on. Yeah, that's right. God, I thought 18 volts on the thing then. It's measuring 1.5 volts already, but that's the power off of the capacitor still. Right, let's see what it's doing then. So let's go up to alright, what's going on here then? Okay, 2.3 volts. .5 at 100. So 240 is about there. What are we doing? 9.2 volts on that particular setting. So let's see what it'll do. Whoa. Let's go up gradually. So 40 milliamps, it's dropping down to 8.3. $70 milliamps, 8 volts. So probably could do with going on the higher setting, couldn't it? Can I get in there with something without knocking everything off? So it needs to come. There. So that's full whack on the last track. So offload, that's 10.7. So yeah, that's probably the setting you want it on. 150 milliamps, 8.7. Let's wind it up a bit further. somewhere. It'll drop off a cliff in a minute. Yeah, so at 600 milliamps, it's dropped right back to half. Yeah, it's dropping off about 500 milliamps. But that's a good supply up to 150 milliamps. It's good enough. So 200 milliamps is doing 8 volts, look. I don't know how hot it would get at that, but yeah, I think you could quite happily leave your radio on all day long with that. I mean, at normal listening, you're looking probably about 40 milliamps. This is very finicky, yeah. So 40 milliamps, look, you're at 9.8 volts. So right, so let me just pop the power off to that. Unplug it, get it out of the way. Always best not to leave stuff connected on the bench, because I've done it many times where you just turn the power supply on and didn't realise you had anything connected to it. So thank you for sending those in, Simon. Very interesting. That little sort of weird and wonderful fuse, I've not seen one of those before. I've seen bimetallic strips many times, but used mainly in sort of cookers, but thermostats, etc. Right, let's clear a bit of space. Right. John, how are you doing? PSU working is proof that miracles exist. Oh dear. Looks homebrew. I don't think it is homebrew. I think it's come out of something. I would say it's fairly old, Sean. I don't know how old it is. Good enough for Roberts, definitely is, Nick. George is saying that these are trucks look straight. Sean, thanks very much, mate. I can eat now. I've got food. Food, yeah. Rob, thank you very much, Rob, as well. George has got a couple of 1960s battery eliminators built exactly the same way in cardboard boxes to replicate a battery. So the only other things I had to look at, and I'm not really going to have a chance to fire these up today because they need a proper going over really, but I will quickly show them. So first one is this one, which is a Panasonic, and it is an RF B45. So it's basically a world band receiver. There's a lot of dust inside the display, so maybe this one has been taken apart by somebody before. I thought maybe the front had been burnt, but it's it looks like it's dished on purpose. Thought it might have had a bit of heat on there, but no, I think that should be like that. I've not had one of these before, so don't know a lot about them, but it will do sideband. It's got SSB on the top. What sort of power supply does it take? 9 volt in, 6 volt in, center pin positive. Somebody's butchered the, someone's butchered it. Let's just pop some power on it quickly. Someone's butchered the power supply socket on it by the looks of it. 9 volts in, current out. Let's pop some power in it. Right, first thing is how do you turn it on? Operation. Sometimes these have got battery main switches on them, but this one doesn't look to have. It's not drawing any current at all. Let's see what the owner says. RF B45 does not switch on. It's prone to on-off switch failures. Notice if I connect it to the power supply, well, it does not work. Disconnecting the AC supply and switching it on via the batteries usually enables it to work. You cannot turn it off unless a sleep time elapses or you pull the batteries out. God. Yeah, doesn't sound good, does it? Let's try some batteries in there. I've got some rechargeables here. Let's have a look. It's going to be Theo, you are, mate. You just caught us. You just caught us in the act, mate. How you keeping, Theo, anyway? Let's just pop that in. Let's try it on the batteries. Okay, yeah, we have got a display on batteries. We've got an E flashing. Dead ass. Is there a reset on it anywhere? Nope. So the power supply's been chewed up for some reason. So I suspect, I'll have to have a look and see if I can find a circuit for it, but I suspect we've got those nasty little electrolytic caps in it. So that's a no-go. But they are supposed to perform pretty good, these Panasonics. I think Aston might know a bit about these because I think they used to work for Panasonic, Aston. Yeah, there is there is a B65 as well, which I think is a bit fancier. So it's obviously got no batteries in at the moment, so it must have a super cap in it or a backup battery. That's the only thing that's working. So I suggest that that's probably going to need a recap, no doubt. And the other one is one of my favourite radios. Can be tricky to work on, but they are a very nice radio. Let's have a look what we've got here. So 4.5 volts, center pin negative. So I'll just swap them around. Just check, make 100% sure I've got a center pin negative. Four and a half volts center pin negative. I wonder if this is a fit or not. Okay, so main power on. Okay, that doesn't appear to be working, but I don't know if I've got exactly the right power supply there. Let's have a look, see what he says about this. This is Jim, by the way. I think Jim was a chap that sent the 7600 in that was absolutely wrecked by batteries. Totally dead. Okay, totally dead. Quite a worn specimen. It did work well until recently, then it gave up the ghost. So the speaker sounded dull and lacking treble response when it was working. Telescopic area, which I installed as a replacement, is not the right one. Unfortunately, you can't get them. You can't get them. And the green display light is rather weak. So again, that could be strange that nothing's happening there. It's absolutely dead. Actually, we've got to have... This is one of these ones where you've got to have the computer batteries in, I think, or it won't work. Yeah, let's try that. You've got to have those in, otherwise it won't work. Weird. Try again. No, still nothing. It's sort of... no, it's not drawing any voltage. No, totally dead. Oh well. Looks like the owner was right. At least the battery terminal's not snapped off on this one. So yeah, again, that's going to have to come apart and have a look inside before we can sort of work out exactly what's gone wrong with that. And it might just be something as simple as the power supply port has come unsoldered. It could be. So there you are, we did have a quick look at them. The only other thing was I've been playing about my power supply. So let's quickly shoot over to my screen and have a quick look at what I've been doing with the power supply. So I've been playing with this Design Spark software. Hopefully I'm on my screen. Yes, I am. I'm in the corner. And I've sort of laid it out as best I can. I keep coming back and adding more things into this, so it's grown. So this is my transformer with my fuse coming in, bridge rectifier. I've now got some decoupling caps across that, main filter cap. Then I've got my LM317 voltage regulator, and I've just popped a couple diodes on across that. I was following a circuit. I've now, instead of putting the variable resistor in there, I've got a bank of 4 resistors, and this is a big rotary switch here. So the idea is that I switch in these 4 resistors for different voltages, and I've sort of have done the maths and worked that out. So I've got 4 to go in there. I've added another cap in here, which wasn't on the original circuit. I've got one of these fuses that Chris recommended, which is a self-resetting fuse. And this is a heat sink. And I haven't done the tracks properly on the PCB yet, but this is roughly where I am with it. I've just done an auto route at the moment to get the tracks laid out. And then I'm just going in and upping the size of them. And just off screen is the switch there. So if we go to 3D view, give you an idea of where I've got so far with it. So this is just a CAD diagram. You can see my switch under there. But this fuse looks a bit big. I don't think that's to scale. I'm not sure. I mean, it's not a huge board, to be fair, but so there's my bridge. There's my caps across the bridge. A couple diodes. I think that's looking all right so far. And I've got my resistor bank in there, and this first one is the resettable fuse. It says that's R5. So I've not done the screen printing on it yet. The silk screening, or silk, I can't remember what they call it now. Silk layer. But yeah, there you go. Story so far, my little variable power supply. There we are, back in the room. Assault on battery terminal. What's that? ZX? Those 2 computer batteries need to be lithium AAs. If you use alkalines in there, a leak, it causes huge damage. Yeah, you're dead right, Doug. Yeah, they do. Cheers, George. So, people, that's it for now. Hopefully that's been of interest. I do need to obviously do a lot more on these 2 radios. I need to get them out of the case, but I've not got time to do that today. I've gone over a little bit. But Mrs. Cruncher's okay. She's fine. Thanks, John. I've only just started learning it, John, so I really don't know what I'm up to yet, but it looks okay so far. I've just got to get all the tracks sorted and work out I've still got a lot of maths to do on it, unfortunately. So if you've enjoyed that, please give it a thumbs up. And if you're not subscribed, then please subscribe. I mean, I look at some of the stats on the videos, and 50% of people that watch the streams aren't subscribed. So please hit that subscribe button, people. It all helps. And we'll check out the contributions for today, which are always greatly appreciated, as you know. And we got Mr. Man Cave, Sean, good man, and Rob Cross. Thank you, Rob. So I'm glad you chaps have enjoyed it. I've got my head on the side there. I don't know what's going on there, look. Anyway, thank you very much for your contributions. And to my Patreons, the Patreon count is going up. So thank you very much to all those that have subscribed to me on Patreon as well. I'll catch you on Sunday. Yeah, Dom is also doing an EDA little design, so hopefully he'll show us that soon. Catch you on Sunday, people. Have a good one. Stay safe, and see you soon. If I can get everything working. Off to do some pizzas now. Bye for now.